Greetings, scholars, and welcome to the wonderful world of chemistry, hosted to you today by me, Sammy, a third-year philosophy major, and...
I'm Joey, I'm a second-year bio major.
And there you have it. So that's us. So now, let's get to the problem.
So to solve this problem, like pretty much any other chemistry problem you might encounter, we should start by identifying what the problem gives us and what it's asking for. So it tells us that in our device we must apply 5.22 times 10 to the negative 7th moles of a polymer, and that it must be applied in a volume of 5 times 10 to the negative 6 liters. And we are also told that the molar mass of the polymer is 147.2 grams per mole, and that we have 2.25 milligrams of this polymer to work with. And what we are trying to find out is in what volume of solvent should we dissolve this polymer. So I like to start by just kind of diagramming what's going on here. Say we have our device, this looks like a little box here, and it has a volume of 5 times 10 to the negative 6 liters, and to this device we need to add 5.22 times 10 to the negative 7th moles of our polymer. And on the right hand side here we have a vial with some dried polymer in it, 2.25 milligrams of polymer, and we are asked what volume of solvent we need to add to our polymer. So, just by looking at this, you'll probably notice that the moles and volume are specified for the device. So this is a given ratio, and in other words it would be called concentration. Moles per volume, moles per liter. And if we're to apply the right amount of moles in the volume of the device, we need to create that same concentration in our vial. And it can be assumed that we're creating excess solution in our vial compared to what we're actually going to be using in the device. So we can say that the concentration in the device is equal to the concentration in our vial. And so we can start by calculating the concentration in the device, which is pretty straightforward. You just put moles over liters. So 5.22 times 10 to the negative 7th moles of our polymer in 5 times 10 to the negative 6 liters. And that is equal to the concentration in our vial, which is a little bit trickier to calculate because the amount of polymer we have is given in milligrams and not moles like it is for the device. So we need to somehow convert milligrams to moles in order to calculate a concentration. But luckily we are given a molar mass of the polymer, so we can convert between mass and moles. So we start with what we have, 2.25 milligrams of our polymer, and since molar mass is in grams per mole, I need to convert milligrams to grams. So there's 1 gram for every 1,000 milligrams, and there's 1 mole in every 147.2 grams of polymer. And this term will simplify to just be the moles of our polymer. And that is over the amount of solvent we're adding, which is our unknown. So I'm just going to call that X liters of solvent here. And so this can be solved just like any other proportion. And when you solve for X, you should get about 1.46 times 10 to the negative 4th liters. And that's our answer.
Okay, so now that we've solved the problem through one method, there is a second method that uses more of a mathematical equation type structure to solve the problem. So we start off with the fact that the concentration of the polymer solution in the device is equal to the concentration of the polymer solution in the vial. And we know from the first problem that we have these 2.25 milligrams of polymer in the vial, and that the device only needs so many moles of polymer and so many liters of solution of that polymer. So, because these concentrations are equivalent, we also know that moles of polymer in the device divided by liters of polymer in the device is equal to moles of polymer in the vial divided by liters of polymer in the vial. Now, if we do a little bit of multiplication, we can get to a much more useful equation that illustrates the ratio between the moles from device to vial and the volume from device to vial. So by multiplying by liters of solution in vial divided by moles of polymer in device on both sides, so that the equation stays equivalent, we can come to the conclusion through some simple mathematical cancellation like this, that liters of solution in vial divided by liters of solution in device is equal to moles of polymer in vial divided by moles of polymer in device. So this is supposed to illustrate the fact that as you upscale the moles of polymer in the device to the moles of polymer in the vial, that ratio is equivalent to the factor that you multiplied the liters of the solution in the device to get the liters of solution in the vial. And now we can restructure this equation so that our target volume, which is the volume of solution in the vial, is equivalent to moles of polymer in the vial times volume of solution in the device divided by moles of polymer in the device. And we know that moles of vial divided by moles of device is equal to 29.31 if you do the calculation based on the moles we got from the previous problem, the moles in the vial, because our mass was only given in milligrams. And we know that number is 29.31, so multiply that by liters of solution in the device, and you should get the same answer that we got in the previous problem, 1.46 times 10 to the negative fourth liters.